Every day, you can see some product around you that was processed in a modern refinery. Gasoline and diesel fuel pumps are obvious. But what about plastics for food wrappers and medicines? Fibers for carpets? Even wind turbine blades? All are the result of refining crude oil. So let's take you through how it works. To a layperson, a refinery may appear to be a confusing maze of towers, pumps, pipes, and tanks. In reality, oil refining is a highly organized and coordinated set of sophisticated technical equipment that makes both physical and chemical changes to crude oil. Before learning more about refining, it is important to understand the basic properties of crude oil. Unlike water, crude oil is not a chemical compound. It is a complex mixture of thousands of different compounds formed from hydrogen and carbon atoms, called hydrocarbons. Like water boiling at 212 degrees Fahrenheit, each hydrocarbon compound, or fraction, has its own size, weight, and boiling temperature range. It is this phenomenon that permits crude oil to be separated into so many different petroleum products. In general, the more carbon atoms, the higher the temperature at which a fraction boils and vaporizes. When you visit a refinery, you'll learn that it is laid out to match the flow of crude and products through the plant. Every type of equipment has a particular task, but all the processes are tightly integrated. Both process and information technologies play a key role in the smooth operation of a refinery. The heart of the refinery is the processing units, often called the on-sites. The first refining process is separation, called distillation, usually the tallest tower in the plant. Let's go inside the tower. Once desalted, crude oil is heated to about 400 degrees Celsius, forming a mixture of hydrocarbon vapors and liquids. With gravity, the liquids drop, and with temperature, the vapors rise. To allow the fractions to separate, the tower has stacks of perforated trays placed at various heights and intervals. As the vapors move up the tower, bubble caps on the trays slow down the vapors. This allows each fraction to cool and condense on one of the trays. Liquid hydrocarbons that form on the trays are drawn off along the length of the tower. Lighter fractions with lower boiling points rise and condense near the top. Medium-weight fractions condense in the middle. Heavier fractions with higher boiling points settle at the bottom. Most distillation fractions do not have the quality needed to be sold as finished products without further treatment. Also, a relatively small amount of desired motor fuels are produced by distillation alone. Distillation fuel yields can be only 10 to 25%, depending on crude oil quality. Today, a large part of refining activity is converting fuel oil, an unwanted product, into high-demand transportation fuels. To improve the quality and light product yield, a series of complex chemical engineering conversion units are used. The conversion tools used by refiners include heat to promote the chemical reactions, pressure to control chemical reactions, catalysts to speed chemical reactions, and additives to improve product quality. One conversion unit, a reformer, that is used to improve gasoline octane will have millions of dollars of platinum embedded in its catalyst. Impurities must also be removed from the fractions through various treatment processes. A key impurity removed is sulfur, which causes corrosion in the plant equipment and fuel exhaust emissions. Finally, blending is performed to combine various fractions to meet specific product quality specifications. Gasoline can have over 30 blended components. We finally have recognizable products from our crude oil. Let's review. Light products with low boiling point ranges include LPG and gasoline. LPG is stored and marketed in cylinders in a pressurized liquid state. Medium products are diesel, heating oil, and jet fuel. Those with high boiling points are called heavy products and include fuel oil, lubricants, and asphalt. Another major product called naphtha is used as a chemical plant feedstock to produce thousands of products seen every day, such as glue, toothpaste, plastic bags, disposable diapers, and even footballs. Today, refineries produce a wide range of fuels not only in transportation, but also for electricity generation, industrial processing, home heating, and petrochemical production. These modern facilities cost billions of dollars to build and tens of millions to operate annually. They are marvels of engineering, using a variety of high-pressure and high-temperature technologies to squeeze the most valuable products out of every barrel of crude oil. We are announcing a new Advanced Introduction to Refining series from EKT Interactive, covering refining operations and business drivers. It includes 10 narrated and animated mobile-ready videos giving you over 2 hours of training. To learn more, please visit us at www.ektinteractive.com.